Hi everyone. In this lecture, I want to continue on modeling two-port circuit. In previous lecture, you saw that we can model a two-port circuit by its impedance matrix. So here I have a two-port circuit, and in this two-port circuit, I have two pairs of terminal. The first pair has a voltage and current described by I1 and V1, and the second pair has a voltage described by V2 and a current described by I2. So here is my two-port circuit. In this two-port circuit, you saw that because we have 4 different parameters and 2 of them are independent parameters, there are 6 different approaches of describing the circuit by selecting different parameters as independent one. So we have V1, I1, V2, and I2, which are the parameters of this circuit, and 2 of them are independent. The other 2 can be described by our independent selection. Since you have 4 parameters and you are trying to select 2 out of these 4 parameters, then it means that you ended up having 6 different choices. So you can choose your independent parameter to be I1 and I2, and this is what we discussed in previous lecture. So if you choose your independent one as I1 and I2, then you have to describe your V1 and V2 based on I1 and I2, and then the matrix that describe this linear combination is going to be your Z matrix. So you ended up having Z matrix. Or you can choose your independent to be V1 and V2. So instead of focusing on the current, you can focus on the voltage and then describe your current based on the voltage. In this scenario, your matrix is going to be admittance matrix. Now in this lecture, I want to focus on Y matrix, which has V1 and V2 as independent parameter, and I1 and I2 are the dependent parameter. So my equation looks like this. I have I1 as Y11 V1 plus Y12 multiplied by V2, and then my other dependent parameter, which is I2, can be described based on V1 and V2 as well. So my linear combination has this form. I have Y21 multiplied by V1 plus Y22 multiplied by V2. So it means that my Y matrix is equal to Y11, Y12, Y21, and Y22 component. Okay, now let's see how we can find these 4 parameters when we are selecting our voltages to be the independent parameter of the circuit. So now I want to show you how we can find Y11, Y12, Y21, and Y22. Okay, let's focus on Y11, for example. If I want to describe Y11, then because I don't know what is Y12, I have to make sure that the second term is eliminated. And that is possible by making the voltage of the second terminal as 0. So if I can consider that V2 is equal to 0, then my equation is only this one. So I can describe Y11 as I1 divided by V1 when V2 is equal to 0. Remember that V2 equal to 0 means that we have short-circuited terminal 2. So it means our terminal 2 is short-circuited. Now, if I'm looking for y12, this time I'm looking for this parameter. So I have to make sure the other parameter is 0. So I have to short-circuit terminal 1. So V1 should be equal to 0. Then in this scenario, I can describe my y12 as I1 divided by V2, with the constraint that V1 is equal to 0. So just to remind you again, this time I have terminal 1 short-circuited. Let's go to the other two parameter. So for y21, I have to make V2 equal to 0, and then I can say that my constant is equal to I2 divided by V1 when V2 is equal to 0. And for y22, I have to make V1 equal to 0, so then I can describe my constant for V2 as I2 divided by V2 when V1 is equal to 0. So as you can see, it is not really difficult to describe the equation here and find the constant that you need in order to describe your admittance matrix. The only thing that you need to remember is that you need to solve this circuit 2 times. The first time you have to make your terminal 2 short-circuited, and when terminal 2 is short-circuited, then you can find y11 and y21. And the next time you have to make your first terminal short-circuited, and in this scenario you can find your y12 and y22. Let me show you how you can solve for Y matrix by an example. In this example, I want to find my Y matrix component. So what I need to do in order to find y11 and y21 is that I need to short circuit terminal 2. So I'll start with that. I need to short circuit my terminal 2. So V2 is equal to 0. If V2 is equal to 0, then here the dependent source will be equal to 0, and consequently I1 will be equal to V1 divided by 1K. So from this equation, I'm going to have I1 divided by V1 as 0.001. So looking back to our equation, I1 over V1 when V2 is equal to 0 is our Y11. Here I have I1 over V1 when V2 is 0. So this number is my Y11. The second parameter that I can find when V2 is equal to 0 is Y21, and that's equal to I2 over V1. So it means that I have to try to find the current of my output terminal. So in my output terminal, the current of I2 is equal to what is going here plus what is going in this direction. Now, because output terminal is short-circuited, no current will go to the resistor, because the resistor is short-circuited and all the current prefer to circulate in the short-circuited path. So I2 is going to be equal to 50 I1. Now, in order to describe I2 over V1, which is equal to our Y21, I'm going to have 50 I1 divided by V1. Now, instead of I1 over V1, I can replace it by 0.001. So multiplying that by 50, I'm going to have 0.05. So up to here, when V2 is equal to 0, I have y11 as 0.001 and y21 as 0.05. I need to find the other two parameters, which are y12 and y22. For these two parameters, what I need to do is that I have to short circuit terminal 1. Now let's look at the circuit and see what happens if we short circuit terminal. So the second scenario that we have to solve this circuit in is V1 equal to 0. So we have to short circuit terminal 1. If V1 is equal to 0, then in the left hand side of the circuit, what I have is a simple loop in which I can find the current coming out of the source by dividing the source value by the resistance value. Now, this current that is coming out of the source is equal to minus I1. So I can say that minus I1 is equal to the source value, which is 10 to minus 4, multiplied by V2, divided by 1K, or 10 to 3. So here I have an equation which describes the relationship between I1 and V2, and according to my set of equation, y12 depends on the relationship between these two parameters. So I1 over V2 is equal to y21, and according to this equation, if I rearrange it, then I'm going to have it as minus 10 to minus 7. So I'm going to complete my Y matrix here. So y12 is equal to minus 10 to minus 7. Now the last parameter I have to solve the circuit for is y22. So I'm looking for y22 here, and y22, according to my sets of equation, is equal to I2 over V2 when V1 is equal to 0. So I2 over V2 when V1 is equal to 0. So I'm going to go back to the right hand side of the circuit. In this circuit, I can say that I2 is equal to the current going this direction and this direction. So I would say I2 is equal to 50 I1 plus the current of 40k ohm, which is equal to V2 over 40k. So V2 over 40k. Now here, I'm looking for a relationship between V2 and I2, so I have to get rid of this I1. What I can do is that I can replace I1 from this equation. So let me write the equation here. So I have I2 as 50 I1 plus V2 over 40k. I'm looking for the relationship between I2 and V2, which describes my y22. So I have to get rid of this term. And on the other equation, in this scenario, I had I1 as minus 10 to minus 7 multiplied by V2. So I'll replace I1 by minus 10 to minus 7 multiplied by V2. So I have 50 multiplied by this term plus V2 over 40k equal to I2. So it means that I2 over V2 is equal to minus 50 multiplied by 10 to minus 7 plus 1 over 40k. If you simplify this number, you're going to have 2 multiplied by 10 to minus 5 as the final answer for y22. So I can complete my Y matrix here, and I'm going to have 2 multiplied by 10 to minus 5 here. Now, if you look at this matrix, you can see that this time we are having different values for y12 and y21. So y12 is not equal to y21. The reason is that we do have dependent source. So the presence of dependent source in this circuit is the reason that we don't have same values for y12 and y21. And that's why that I was calculating both of them in my solution. So whenever you have a dependent source, you have to solve for every single parameter for your Y or Z matrix. But if you have no dependent source in your circuit, then you can assume that these two parameters are equal and you can only solve for one of these two. The last part that I want to talk about here at the end of this example is that the question is that how we can relate Z and Y matrices. So let's assume that I have the Z matrix for a circuit and I want to know what is the Y matrix of the circuit. Should I calculate all those elements in Y matrix again, or I can find it from Z matrix? Or the other way, if I have Y, is there any way to find the elements of Z matrix? So I'm going to show you the relationship here. So if we have Z matrix, then it means that our dependent parameters are V1 and V2. So I'm describing them in terms of Z matrix multiplied by my independent parameters, which are I1 and I2. Now, if I have Y matrix, this time my dependent parameters are I1 and I2, and I'm trying to describe my dependent parameter in terms of the independent ones, which are V1 and V2. So as you can see, the first one, let's show this one with capital V, vector of the voltage, and the current by capital I in this form, the vector for the current. So the first equation is telling me that the vector for the voltage is equal to Z multiplied by I. And in the second set, I have the vector of current as Y multiplied by the vector of the voltage. So it's very clear what is the relationship here. Obviously, Z is equal to Y inverse and Y is equal to Z inverse. So if I have Z matrix and I'm looking for Y matrix, I have to find the inverse of Z, and that's going to be my Y. And if I have Y and I'm looking for Z, then I have to find the inverse of I, and that's going to be my Z matrix. So up to here, you saw two different ways of modeling a two-port circuit. The first one is with impedance matrix, and the second one is with admittance matrix. And you're not forced to find both model, and if you have one of them, you can easily find the inverse of your matrix, and that's going to be the other way of describing it, the circuit. Now remember that one of them, which is Z, works based on open circuit model. So for Z, you have to use the open circuit situation. You have to make your terminal 1 open circuited, terminal 2 open circuited, and solve your circuit in these two scenarios. For Y, you have to solve your circuit in two scenarios, in which one of them is input short circuited and the second one is your output short circuited. So with Y, we are dealing with short circuiting the input and output. With Z, we are dealing with open circuiting the input and output.